Alright, so we are still doing direct and inverse variation story problems just like we were yesterday. Yesterday was more of just an introduction, and we're just going to really dive in today, try to do as many examples as we get to. So just to remind you about the two types, direct variation, that hole punch kind of took that word out. Direct was when you have the equation y equals a times x, right? They're being multiplied together. A couple of things that we kept in mind yesterday was that it was a linear function, but it has to pass through 0, 0, or the origin. All direct variations have to do that. And as far as words that you would see that would tell you that you need to use this equation, you would look for the words either directly proportional, we're going to see more of that today, or varies directly. And we saw that yesterday with the two story problems as well. Okay, so that's pretty much it for direct variation. You just have to remember to use the right equation if it says the word varies directly versus inversely, which is what we'll see on the next part here. Okay, any questions? All right, inverse variation would be y equals a divided by x. So again, you have to know the equation for it, where a is always the number that you're looking for. Once you find a, you plug it back into this equation so you have a generic equation to work with. Remember for this, it's a hyperbola for the shape of the graph. That means, if you're not familiar with that word, remember it's like two branches. It's kind of the way to think about it, two curves, one in like one quadrant, usually first and third quadrants. They can switch though. And then as far as what words you would see, it would only say varies inversely. It doesn't usually use any other words to explain that you need to use this equation. And so this a that shows up on both of the equations, it's called, so I'm going to write it here, a is a constant of variation. It just shows you, it's like a number that shows you how the two variables are related. Because the two variables can be any two variables at all, and we're talking about, are they related directly or are they related inversely? Depending on each situation, we'll look and see what it is. Okay, here we go. With the first example, we have a table this time. Sometimes a table makes it a little bit easier to see what type of, if it's direct or inverse, and we're going to do more with tables tomorrow. But if you notice here, 0, 0, that means that if this is actually linear and it's passing through 0, 0, that would be direct. So let's just make sure it is linear. Because it says, Janelle planted ornamental grass seeds. After the glass breaks the soil surface, its height varies directly. So actually it did tell us right away that varies directly means you're going to use this equation. Y equals a times x. But again, if you're looking for the slope, it would be adding 2.5 every single time. That is your a value, the number that you add every single time. Sometimes tables will make it easy for you to see that, sometimes they won't. So that's why tomorrow we'll do more harder tables where they don't show us kind of numbers in order. What if it's all mixed up, like it goes 1 and 30, and then it goes to 4 and 80 or something like that. So now that we want to write our equation, it says, first of all, to answer these three questions, it says, what's the rate of growth? That's 2.5. And 2.5, you want to make sure you have units with it. So look at what the x and y variables are. Height is in inches, and then the x value is days. So it's an inch per day. That means that the plant, or this grass, is growing 2.5 inches every day. Okay, then it says now write an equation to model the height h after d days. So instead of using x and y, we need to use h and d. And so you can pick one number or one pair of numbers, x and y, from the table. It does not matter which ones you pick. You get to pick any x or y. I don't want you to pick 0, 0 though, and that's just because it won't help you find any information. If you want to just solve this how we've been doing it yesterday, all you would do is grab a point, substitute it in for x and y, or in this case h and d. So it'd be 2.5 equals a times 1. That means a is 2.5. Okay, but again, you didn't have to show this work if you already saw that 2.5 is your slope, right? So the equation is h equals 2.5 D. All right, and then what will be the height after 10 days? All you have to do is substitute 10 in for D, because that's what D stood for, days. So H equals 2.5 times 10 comes out to 25, but again, think about what your answer should be with units. Height was in inches, so that's inches at the end. So the grass should grow to 25 inches tall once it's been 10 days. All right, that was our first example. We're going to do a couple more. Sometimes you won't have a table. Like the next one, we're just going to have a little scenario. We'll read through it, try to figure out how it varies inversely or directly to decide on an equation, substitute the numbers in, and then find A. So first, this one here, example 2, says the time t, so that's the first variable. The first variable, when you read through it, is always going to be the one that comes before the words varies inversely or varies directly. It's going to be your y. And you can label it with y if you want to, or you don't have to because they already gave us a letter to label it with. So when we get there, we'll change it to a t. It says the time required to empty a tank varies inversely with its pumping rate, and that letter they gave us is r. But again, it's another way of thinking about it as x. Then it says the rate, or R, of a certain pump is 70 gallons per minute. So this is my R, or my X, however I choose to think about that. It takes the pump 20 minutes to empty that tank. So 20 minutes is a time, so that's going to be my, I'm going to write T here. Or it's the same thing as your Y. Okay, so first thing you want to start with is, if you want to, you can start with Y equals A over X. Or go immediately to using T and R. T is, again, time. R was the pumping rate. So this would be T equals A over R. But it does have to be in this order. If you were to change the order, then you're actually figuring out a different equation. You're not doing it in terms of time varies inversely with pumping rate. You're doing it the other way around. Okay, we plug numbers in now. So time was 20 minutes. And the rate was 70 gallons per minute. And then you're just asking yourself, how am I going to get A here? I have to multiply by 70 to get rid of it in the denominator here. So then I get 70 times 20 is 1,400 equals A. But again, don't forget to substitute it back in. So that our equation here is y equals, actually I want to plug it in here for this A. So it'd be T equals 1,400 over R. That's all you have to do for the first box here, because it says write an equation that models time as it takes to empty a tank as a function of the pumping rate. That's my equation. And again, the reason they say it this way, as a function of the pumping rate, that means that you have to put T equals instead of R equals. Okay, so now the second part of the question, you have to take that equation you just came up with and keep plugging in numbers. We have 14 minutes, 10 minutes, and 5 minutes, and that's all going in for T, time. We're figuring out what the rate would be for each one. So 14 equals 1,400 over R. Now, when it comes out to something like this, it's a little harder to solve. Yesterday we saw ones where we substituted numbers in for R, and it was just easier. We grabbed a calculator, you divided the two numbers. Here, we're trying to solve for R, so I actually have two choices. I can either make that a fraction and cross multiply and solve, or I can multiply both sides by R. And the only reason I'm doing that is so that it cancels out on the denominator there. Now I'm looking at 14R is equal to 1,400, and then divide by 14. So this one takes a little bit longer to figure out. Instead of just grabbing a calculator, you have to walk through how am I going to solve for the missing variable R. So 1,400 divided by 14 comes out to 100. And remember, the units here are gallons per minute. So that's how fast that water, or I think it just says it's emptying the tank. We don't know what it is. It's taking 100 gallons. It's going that fast. And every minute, 100 gallons will be emptied out. So that you get a total of, it takes 14 minutes in total. All right, same idea with the next one. 10 equals 1,400 over R. If I wanted to this time cross multiply, let me show you how that would work. So you would do 10R is equal to 1400 times 1, or just 1400, divide by 10, and you'd find out R is 140. Again, gallons per minute. Okay, and then the last one was 5 minutes. That's what we have to substitute in for T. For the last case, I'm going to put it right here. 5 equals 1400 over R. And again, either cross multiply to solve here, or multiply by R first. So you get 5R equals 1400, and then divide by 5. So we get R equals, this one was 280 gallons per minute. All right, and then all we're doing here is graphing it, like plotting the points, seeing what the graph looks like. Since it was inversely, it should have that hyperbola, or like one of the two branches. Bless you. So the two branches here, we won't actually graph both, only because in context, again, time can't be negative, that rate can't be negative. So the points we're graphing are, when we plugged in 14 in for T, that T was like your Y though, it was 100. So 114 is the coordinate that we're going to plot. So make sure you understand why, that it's this way and not the other. Remember, rate was like X. I wrote it right up here, rate was X, and Y was time. That's why it went 114, or the next one was 140, comma 10, and the last one is 280, comma 5. So my Y values go from 5 to 14. My X values, though, go pretty large. They're going all the way to like almost 300. So when I pick my X values here, I think I went by 50s. That should be enough to fit everything. So 50, 100, 150, 200, 250, and 300. Kind of hard to see there, but again, it's jumping by 50s. And then vertically, you can go probably by just 2s, because you just need to get up to 14 as the highest number there. So 2, 4, 6, 8, 10, 12, 14, 16. You could stop there because 14 is the highest we go. All right, so at 100, go up to 14, put a dot. At 140, so a little bit under 150, you're going to 10. And then finally at 280, you get only up to 5. So those are the only 3 points I have. It is enough to graph this out, though, like this. You could also add in the point for 20 minutes, how the original problem had it. 20 minutes it took, or I'm sorry, it said, yeah, 70 gallons per minute and 20 minutes. So that could be another X and Y that you could potentially take, where 70 would be your X. So you could come up here at 70 and put at 20, but 20 wouldn't quite fit on this graph. All right, that was all of the second example. So we're going to try maybe one more, and then I might have you guys try some for practice, because they're all very much the same concept. Okay, so the next one here is another varies directly. It says a wave's length is the distance from its crest to the crest of the next wave, and the height h at which the wave breaks varies directly with its length. So you want to look out for that sentence where it says the height h, there's the first variable they mentioned, at which the wave breaks varies directly with the length. The order of those variables does matter, because the first one that they mentioned before the word varies directly is always your y, and the second one is always your x. So a wave that breaks at a height of 3 feet, this is my h, or my y, 3 feet, has a length of 21 feet. So this is L or x. Okay, so the first thing you do is it varies directly means y equals a times x. But instead of using x and y again, we're switching it to h and L in that order. H equals a times L. And I'm just using that cursive L so that you can see that it's an L and not a 1. Or you can do a capital L if that would be better. Actually, yeah, that's what it is. I'm going to change it to capital L. So it's a lowercase h but a capital L according to the just what it's written down as, but you can choose All right, so let's substitute numbers in. Height was 3 feet, and length was 21 feet. All right, and then we find A by dividing by 21. You can write it either as a fraction or a decimal. It's 1/7 as a fraction. Not sure what it is as a decimal, but you can type it in. And plug it back in. Make sure it goes into the equation with the h and the l. So h equals 1/7 L, or times L. So at this point, this is your equation for the first part. And 1/7, just because it's a fraction like that doesn't matter. It's still going to be considered a direct variation equation. It's not inverse just because you see a fraction, because L is not in the denominator. All right, then it says, okay, well, answer the following questions. So use this equation for the second part. It says, how high is a wave whose length are the following? So we're plugging these numbers in for L. So 1/7 times 2. I'll just write them all out first, and then I'll grab a calculator and try to find them all. 1/7 times 5, 1/7 times 7, and 1/7 times 14. And it's okay to get decimals for all of these. And remember, the length is, it says how high is a wave. The height is measured in feet. So the answers here are 0.29 feet, 0.71 feet, then we get 1 foot, and then 2 feet. All right, and then the last part is plotting the points, seeing what it looks like. It should be a line because it's direct variation, and it passes through the origin. All right, so we're plotting these points. The x values are the ones we put into the parentheses, so 2, 5, 7, 14, and then the y values are what the answers were. So at 2, it looks like for my x values, I have to go from 2 to 14, so I'm going to jump by 2's here. 2, 4, 6, 8, 10, 12, and 14. For my y values, I only go between 0.29 and 2 feet, so it might be better to spread it out a little. So I'm going to go by 0.5s. 0.5, 1, 1.5, 2. Even though you could even spread it out even more, go by 0.2s or 0.25 if you want to. So the first one here, 0.29, at 2 I'm going to only up to 0.29. So, oh wait, I think I'm off here. Try that again. So it's 0.5 for the first one, then 1, 1.5, and then 2. So at 0.29, 2, it's about there. At 5, I want to go up to 0.71, so about there. And then at 7, you want to go up to 1. And then at 14, all the way across 14, go up to 2. Alright, and we connect all of those. Looks like that. Now, it technically doesn't show that it's crossing through the origin, but it will. You can even have a point on the origin if you want. But as long as you see that it's a line passing through the origin, if you want to dash the other side of it, you can. Just saying that the line would extend to the left as well. But in context, it doesn't make sense. We can't have a negative height or a negative length for a wave. All right, so I'll go over maybe one more, and then I'll pass out the homework so you can get started on the homework, or you could try a couple more of these out for some more practice. So let's see, let's do, we're going to go ahead and do example 5. The answers, though, if you want to try example 4 on your own later, this would be, equation would be t equals 97.5 over s. Those are the two letters we were asked to use. And then it says, well, how about if you're driving 55 miles per hour, how long would it take? It would be 1.8 hours. So again, if you want to try example 4 out a little bit later, go for it. I'm going to just work through example 5, because when you solve for example 5, it's a little different. I want to make sure we see one of those. And then I'll put the answer up for example 6 as well if you'd like to try it. So it says the amount of sales tax on a new car is directly proportional, direct again, to the purchase price of the car. So the sales tax is Y, and the price of the car is X, the actual car price. So it says if a $25,000 car, that's how much the car is worth, that's your X. So if X is that $25,000, and you would have to pay $17.50 in sales tax. what's the purchase price for a new car that would cost $3,500? So again, to start off, you're just writing y equals a times x because it's direct. We're substituting in the two numbers 1750 for y and 25,000 for x. And then you solve for a. Always solve for a. So we divide by 25,000, and our calculator, the answer comes out to is 0.07 as a decimal, or you can write it as a fraction if you want to. But remember, don't stop until you've substituted it back in. So plug back in. So really my equation here is y equals 0.07x. Okay, now I'm ready for the second part of the question, which says, what's the purchase price of a new car which has $3,500 in sales tax? So sales tax, remember, was y. According to that's why I want to label everything when I read through it. If y is sales tax and I'm substituting that $3,500, it has to be in for y. So really, this is the equation I'm looking at. Once I've used the equation I came up with, this was the new equation I came up with, I substituted 3,500 in for y, not for x. And then you just grab a calculator if you need one. You are dividing by 0.07 to solve for x. And that comes out to 50,000. And don't forget dollars, because we're talking about the price of a car. So that original price of the car would be $50,000 if you were paying $3,500 in sales tax. All right, and then the last one, I'm going to go ahead and just write the answer for again. If you want to try it out, you can. Y equals 130 divided by x is what you should get for the equation for, it was an inverse variation one. And then once you start solving again, you get x is 52 degrees. That's how much temperature would be needed, the temperature to melt 2.5 hours out of this block of ice. All right, so again, if you want to try out examples 4 and 6, go ahead and do that if you'd like to right now, or I'll pass out the homework and you can decide what you'd like to work on. All right.